If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay students, let's welcome to lecture 2 of this complex number theory discussion. So today we will be starting with CR equations in polar form. We will be seeing what is harmonic function and some properties of analytic function and how we will construct these analytic functions. Okay then let's start. So until last class we have seen what is the sufficient condition for a function to be analytical. Now if you see the CR equation in polar form it is always del u del r equal to 1 by r del b del theta and del u del theta equal to minus r del b del. Now how to remember this one? This is again a easy one to remember. I'll give a trick to remember this one. Oh, now what is the trick? The trick is, if you see here, the trick is something like that. Here instead of z we are writing r e to the power I theta. That is in polar form. That's why it is known as polar form. Earlier you were using Cartesian coordinate x axis y axis. Now you are using r and this theta to represent the point. This point can be represented 2, 3 suppose. So you will say this point can also be represented r, theta. R will be some distance from here to here, theta will be some angle. So this is the polar form representation. So if it is polar form representation, you just recall one small thing I will give you. Suppose this is my r, I want to go little bit more r, so it is dr, and suppose this is theta and I want to go little bit more, so it becomes d theta. This small portion you can see. So if I take only this portion, what is this area? Normal area in xy plane it is dx dy, small x small y. In here it is a rectangle if it is very small enough. So here one side is del r. Now what is this side? Now if it is you can recall your circle. What is circle? Circle, if you take radian, what is 1 radian? Theta is in radian suppose. So if the distance is of the arc length is r, so let me do it here. If the arc length is equal to r, then the angle it is created is known as 1 radian. The angle it creates, it should be r if it is r. That is the definition of radian. So how to find the length of a arc? Length of arc is always r into theta. Theta is here d theta. The length of r, because if it is r then it is 1. The length, if it is 1 radian, the angle is 1 radian, then the length of arc is r. So if it is theta radian, then the length will be r into theta. So you recall this one. So these are small things. So this position will be r into, what is the angle? D theta. So it is r into d theta. So you remember this side is always r into d theta. So whenever d theta will come, there will be always r along it. So it is a pair. It will never go outside. You can think of this one also in change of variable in partial derivatives. I have told you to give some penalty. Jacobian from one axis you are shifting to one axis, from xy to you are going r theta, then some penalty you have to give, that is known as j, and this penalty is here r if you go for Cartesian to polar. So here you remember this one r d theta. So d theta and r they are a good pair. They are a very strong pair. They are in a relationship. You can see. So if you say they are in a relationship, then how the Cauchy-Riemann equation was written? Del u del x. So del u del r it will be was del b del theta. Del u del x equal to del b del y. But there will be a strong relation between r and d theta. So r should be multiplied. And what was another one? Del u del y is u theta is equal to minus del b del x. Del b del x is r, but there is again a strong relation between r and theta. So either you put r here or here, both are same. So you can see this is your CR equation in polar form. So with this you can remember, because there is a bonding between r and theta. You remember there is a bond between r theta, so you can easily remember. Whenever you write d theta, you write r with that. That's it. Now what is harmonic function? A function phi, which is a function of x and y, it is harmonic if its second order partial derivatives are continuous and its Laplace equation they satisfy the Laplacian operator. That is this is known as Laplacian operator. This nabla square. You remember nabla in vector calculus, del xi, del y, del yj. So here nabla square, that is Laplacian operator, known as Laplacian operator, which is equal to del square del x square del square del y square. So if you operate it on phi, it should be, if it is equal to 0, then it is known as harmonic function. Just remember our definition, what is harmonics, so that it comes, you should not think that it is coming from somewhere else. Just to remember the notations, symbols. Now what is the property of analytic function? If your function fz is analytic, then we will say u, v both are harmonic function. Analytic we have discussed, it should be differentiable, simple thing. So if it is differentiable everywhere, then your u and v, they are harmonic function. That means del square del x square u, del square del y square u is equal to 0, del square del v, del square by del x square of v, del square del y square of v is equal to 0. So that's it. So just property, remember that's one. Questions may come. If f another function, if it is analytic, then the curve u and v, these two are separate function of x and y. You have already seen, if I show you the first class I have shown you in the earlier class, your function, this was your u, this is your v. So you can see u is a function of x and y, v is also a function of x and y. So u will represent some sort of curve and v is also represented something in the coordinate geometry. So u represent a curve and v also represent a curve if I fix the value of them. And they will cut each other like orthogonally. Orthogonally means the point they will cut, if you draw the normal, if you draw the tangent, they will be at 90 degree to each other. If the two surfaces, suppose these two surfaces is cutting each other orthogonally, that means a normal coming out of film, a normal coming out of this will be a perpendicular. And if it is a simple curve, then it is tangent. But if it is a surface, then it is normal. So okay. Now how to construct analytic function? The construction becomes a little bit lengthy. So, but still you have to know how to construct. Suppose a real part is given to you, because the function fz will have two parts, u and v. Fz will have two parts, u plus iv. Suppose this part is given to you or this part, there can be two cases. So this is case 1, suppose this is given, so you need to find the whole thing, and case 2 only this one is given, so you need to find those things. So if you go for case 1, real part is given to you, so you take differentiation of real part, del u del x, del u del y, you can easily take. Now you know what is the differentiation. Differentiation you can go any direction. So for construction we are going in only in x direction, because in every direction the answer should be equal, because it is analytic. They want to form the analytic function. So with respect to x, this is del u del x plus I del v del x. Now use Cauchy-Riemann equation. So because you don't know v, so you want to replace that v. What is v? V is equal to a little modification. It will be del u. So it will be del u del y, del u del x plus I del v del x will be del u del x minus, instead of del v, because we don't have v, so everything is in u now. So you have both these things. Now you put x equal to z, because I am moving in x direction only, because I am moving in x direction. So z will become my x and y becomes 0, because in x direction only x will be there. So you do this one, so you will find f dash z, and then you just integrate this one over z, you will get it. Reverse thing in for imaginary part. Suppose v is given to you, then what you will do, you will take differentiation of v, and in the second step you will try to form it. Again we are moving in x direction only, so you don't have v, so you just replace u by v by using CR equation, del u del x equal to del v del y, using CR. So again you will put x equal to z, y equal to 0, because I am moving in x direction only, so you can get f dash l, and then you integrate it. I think that's all for today. Complex integral we will start in next lecture. If you like the video, then press the like button and please give your valuable comments in the comment section.